Hey everybody, this is Larry. This is me over Q4 of the weekly contest 490, count sequences to K. Hit the like button and subscribe and join me on Discord. Let me know what you think about this problem, this contest, everything in between. Yeah, so I think this one, honestly, for me, I didn't take that long to think about it. I look at the constraints and I thought, well, 19 is small, but we have three decisions to make at every index, right? You can leave it change, or sorry, you leave it unchanged, you can multiply, or you could divide. So three choices, that's 3 to the 19, which of course is too big. However, right, we see the 6 bit. And what does 6 means, right? That means that, well, every number can be only 1, 2, 3, 4, 5, 6, right? And as a result, well, what does that mean? Well, that means that there's only 3 prime factors within them, right? 2, 3, and 5. Well, so then now, if you think about a number as the numerator and over denominator, because then that's how you get, because you want it to be k exactly, so you're dividing stuff. Multiplication is easy, but when you divide stuff, you get a fraction. Hopefully, I don't have to explain that. But now you have fraction, you want to be able to reduce it so that it doesn't. You want to reduce it so that you have to, what was it called? Like the least common factor, is it? No, I don't know. But yeah, just like the most reduced form, right? And the way that you do that is by factoring the top and factoring the bottom, the prime factorization. And once you do that, then now you have either factors left over on top or factors left over on bottom. And in this case, there's going to be 2, 3, and 5, right? Yeah. Let me give you an example. Let me draw it out because I feel like I talk a lot sometimes and I don't give an example, right? Or at least I don't draw an example, which people are always annoyed about. But yeah. So for this, like we have a number, say, I don't know, 18, right? 18 is going to be 2 times 3 times 3, right? And then maybe on the bottom you have, I don't know, 60. 60 is what? 12 times 5. What is that? 2 times 2 times 2 times 5, something like that, right? Maybe I'm wrong, but yeah. And then now to reduce this, you could just say, like, if it's 18 over 60, you just get rid of the extra ones, and then now you have 3 over 2 times 5, which is actually 30% or whatever. But anyway, that part is not important. But that's kind of the idea that we have, right? So then now, instead of keeping track of this fraction, and you certainly can, you could just keep track of how many 2, 3s, and 5s, because you're only going up to 6. You have no other prime factors. You could keep track of 2, 3, and 5 on top, and 2, 3, and 5 on the bottom. Or you could combine them with deltas, right? Meaning that, it's the same thing anyway, right? Meaning that you have number of 2, 3, and 5s on the top, or minus the number of, because you can rewrite this as 3 times 2 to the negative 1 times 5 to the negative 1, right? Yeah, right? So that's, and then basically now, and maybe you would reorder them to 2, 3, 5, but now you just care about the deltas or the exponents, right? And that's kind of the, you don't need this per se. You can YOLO, but what this means is that, okay, for every number, let's say you have 2, you can have 2, 3, or 5, but it only goes up to 6. So then, so that means that if it's 2 and 5, 2 and 3, sorry, if it's 6, you have 2 and 3. That means that you have one contribution to it, right? Meaning that you could multiply or subtract, or addition or subtract the exponents. And in the 2 case, you can actually kind of go up to 2 for 2 to the 2 for 4, right? Then as a result, then now, you just keep track of the exponents for 2, 3, and 5. As we said, change the colors real quick. As we said for this one, because you can do 2 on each one, so this goes up to what is it, 19? 19 times 2 is 38 or something, right? This one is just 19. So those are the number of possibilities on if you add them. If you subtract them, it goes the other way. So if you kind of multiply these by 2, and I think you have to add in 0, but whatever, it's like roughly speaking. I just say that this is equal to 80 times 40 times 40, right? So that's the number of possible fractions that you can have. And it could be a whole number fraction, but that's the number of fractions you can have. And then now it's just this times n, right? Because at every step of the way, you can have some subset of these numbers. And a lot of them are not even possible. Because, for example, you can't have 2 to the 38 after just one number, because it's just too much for one number, right? So a lot of these are not possible, but this is a strict upper bound. It is an upper bound in either case. Maybe it's not tight. Times n. And if n is equal to 19, then just do the math. And I don't know what the math is, but it is small enough and good enough for us to do. And that's kind of the analysis. And that's the tricky part about this problem, because I didn't write it this way, because I YOLO'd a little bit. The way that I did it is, but it's still the same math, same complexity, just a different implementation, right? So for each one, I have the fraction of numerator, right? Then is denominator. And index is just the index on nums, right? And that's it. If we're done, we count them up, and this is a very straightforward dynamic programming, honestly. If you're done, k over 1, then return 1, otherwise we return 0. And then you just all do the 3 possibilities. You keep this the same, you multiply, and you subtract. And also, just to keep things in bound, the way that I did this is a little bit different, because I just have the numerator versus denominator, and not the same as the proof. You can't do it the way with the proof. You can convert this to, say, f of 2s, 3s, 5s, and index, right? So it's just exactly the same. It's just because for every numerator, you could decompose it into this, and denominator as well. And so these 2 numbers uniquely determines these 3 numbers, and vice versa. Well, maybe not technically. Vice versa. So this is equivalent, right? Even though this looks very awkward, but these 2 are equivalent, because with these 2 numbers, you can create these 3 numbers, and because they have the same O of 1, because you could translate from one to the other in O of 1. This is a good enough test for the bound, and yeah. And so this is the way I implemented. But to kind of keep the numbers actually like match what we have here, we need to do the GCD, right? And I just have a GCD function to give it. Well, technically, I don't have the GCD function, but I used the library. But I just kind of reduced the numerator and denominator, because otherwise you don't want to recalculate. 4 over 2 is equal to 2 over 1, but if you don't do this GCD, it would recalculate twice or whatever, and it would just have a bad time. And that's basically the idea. We do one for multiplication, we do one for division by multiplying the denominator, and that's it. And then we just start with 1 over 1. And and I did this, I think, very quickly. I spent a lot of time, like, make this smaller so it fits on screen a little bit better. I spent a lot of time just double checking and thinking about the proof, but otherwise I thought this was pretty straightforward. Well, I wouldn't say this is straightforward, and I did YOLO a little bit even during the contest, because I didn't do a full proof. But honestly, it was just because I knew that this was correct. Just to be clear, I knew that this was correct. The proof would have been for the timeout, like if it's fast enough, and as soon as it's fast enough, I didn't know that. I thought maybe there's a possibility that I need to do some optimization afterwards if this was too slow, but thankfully, it was a little bit YOLO. That's all. But yeah, that's all I have for this one. Keeping in mind that the complexity, the number of possible inputs is, as I said, it's going to be like 80 times 40 times 40 times 20, right? And each input does all of 1 work, so that's your complexity. And that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And yeah, you could watch me try to solve this live during contest now. Maybe this should be okay. Hopefully no. Okay. I wasn't sure, because it's just, with if statements and copy and paste if statements, it's just so easy to make a mistake. I was not confident about it at all. Okay. Q4, integer nums. and k start with value is equal to 1, process nums from left to right. At each index, you must choose one of the following actions. I'm having too much fun. Multiply value by it, divide it by nums, or leave it unchanged. Value is considered equal to k if only its final ratio is exactly. Okay, so I guess there's no like zeroing or 4 or whatever. Return number distinct sequence. Oh, I see. So it's some sort of DP probably. Oh, especially with this 20, then maybe it is DP-ish, but maybe brute force. And numbers is only up to 6. That's interesting. But it's not quite like you may have to do something a little bit smart because it's 3 to the 19, but maybe there's what's 3 to the 19 anyway? I think it's too big though. 3 to the 19 is, yeah, definitely way too big. So what is the thing that I'm trying to be smart about? If it's not brute force, is it brute force? A lot of people seem to have solved it though. I don't know. I'm going to YOLO, but I honestly do not know. Right? Like I don't know how to prove these two bounds. What will we do before we go then? Okay, fine. If num is equal to k and then is equal to 1, then we return 1. Okay. Now we just what's it called? Multiplier of num times num. So that's actually pretty bad. But okay, index. Then index plus 1, right? I mean, I have to rewrite this, but it's fine, maybe. I have to rewrite this. We start at 1. I just want to see if this actually would give me the right answer before I do it. 0 is wrong, right? Oh yeah, I didn't actually write the thing. What I wanted to do was but we need to cache it. We have to do it pre to cache it a little bit better. Okay, so yeah, let's how do I want to write this? Because it doesn't catch enough. Is I mean, yeah, it's fine. Let's just write it in a dumb way, right? Okay, fine. By definition, this should not be necessary, actually. Nope. This is just ignore. Ignore. All right. Maybe YOLO. Do I have to mod? No, no, because 2 to or 3 to 19 should be big enough. I don't know if this is. I didn't even have time to finish my sentence. I thought it would be a little bit harder, to be honest. Because I was very worried. Like I spent, like I definitely like paused, not because of the difficulty, but just because I didn't trust myself, to be honest. Because I wasn't sure that I was going to be correct, but that seemed a little bit easier than I expected. Like I said, so that's which I'm some, and you could say it's just due to a lack of confidence, but. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, this problem, everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.